Hello, I'm Hyuk-Jin Won with Hyejun Lee. We both are Databricks software engineers, and then we are going to talk about the Project Zen today. Project Zen is the effort to make PySpark more Pythonic and easier to use. So this project was started early in Spark 3.1 development, and this talk will show how the Project Zen makes the data science easier with PySpark. So I'm a software engineer at Databricks, and I'm also a member of the Apache Spark PMC and committer, and I also maintain Colas. Hyejun also works for Databricks, and he also maintains Colas together. We both are fairly active in Spark development. All right, so before we start to talk about Project Zen, I will explain a bit of background first. So the first figure shows that the trend of the questions in Stack Overflow and then Python-related questions have rapidly increased. The second is the stacks of codes in GitHub, and then the Python took the second place. Python has grown rapidly in the last few years, and then it became one of the dominant programming language. Apache Spark community took that such kind of trend seriously, and then we initiated the Project Zen to increase the Python usability in Apache Spark. So it provides a better user experience to the Python users. The goal of this project is pretty simple. It's just to make the PySpark more Pythonic and easier to use with working better with other Python libraries. So this is the agenda of this talk today. So I'm going to briefly go through what's done in Spark 3.1 first. So firstly, Python type hints in PySpark that allows a bunch of cool things like auto-completion and the newly designed PySpark documentation that improve the readability with a lot of useful pages. And lastly, the Python dependency management with Conda, virtual env, and packs. And then Hyejun will continue what's done in the upcoming Spark 3.2. That is Pandas APIs on Spark and visualizations like Spark, like plot. All right, so let me start with the Python type hints in Spark 3.1 first. Python type hints are the official way of annotating types in Python. The example here shows it before and after the PySpark type hints. It has a function called greeting that takes a string and outputs a string. With the type hints, you can know what's expected as an input and output easily. So the type hints make the codes easier to read. This is actually not only the benefits. The Python type hints can be effectively useful in IDEs and notebooks that the data scientists use in their daily work. Without the type hints, IDs or notebook cannot support the auto-completion very well. For example, without the type hints, you trigger the auto-completion for Spark context, and it shows like random attribute and method. It doesn't show what APIs it has. This is not the problem in IDEs, but more because of the Python's doc typing. In Spark 3.1, we added the full support of the Python types. So it provides a complete and auto-completion. So like IDEs, Notebook now has a full auto-completion support. Now in notebooks like Databricks or Jupyter, you press tab and it shows the full list of the APIs available. Besides the auto-completion, Python type hints can also automatically document input and output types in API documentation. This improves the development efficiency. The developers don't have to take care of the documenting input and output types. And users can expect a consistent documentation for arguments and return types. If you're already using Spark 3.1 with IDEs, you might have noticed that your IDE detects such errors statically. It warns when the types are mismatched. Because of the doc typing, the IDEs couldn't detect such errors before. But now PySpark has the type hints that IDE can understand. So IDE can enable such static error detection out of the box. It prevents developers to make mistakes like using wrong types for input and outputs. Another thing of the cool thing in PySpark 3.1 is the newly designed documentation. So here is what you see now in Spark 3.1 PySpark documentation. It has a search box, so you can search other pages easily, and it has sidebars to navigate more effectively. One of the things that I like most is API reference. So previously, the PySpark documentation had one single page that lists all the APIs. It was very difficult to navigate one API and hard to search related APIs together. There was no proper logical grouping before. But now it has a proper grouping with a proper structure with hierarchy. Each module has a each group with a table and lists of APIs. And each page has a its dedicated page with a sufficient example and the descriptions. Also, the new documentation has a quick start where you can run the examples in a live notebook out of the box. So it launches a Jupyter notebook for you, and then you can change the example and run one by one without any extra step or installation. Lastly, we migrated the documentation style to numpydoc style. Many other data science libraries such as Pandas or Matplotlib already have chosen this style. NumPy documentation style provides not only a good readability in text format, but also is supported by many other external tools like Spinkis. So the documentation can be generated automatically. All right, so also Spark 3.1 has the complete support of Python dependency management. So you can use Conda, virtual env, and packs to ship and manage the Python dependencies for your codes. So suppose that I'm sort of newbie. So I don't know any of Spark, cluster, big data. I just heard that my company has a Spark cluster. So I just downloaded the Spark client. I copied and pasted the example from the PySpark documentation, of course, without reading them closely. And I ran it and it failed. Then it said that I have to install Pandas and PyArrow. So I did. I did the pip install Pandas PyArrow. I checked the versions too. And now looks like I can define the function. So I'm going to execute and print out my data frame. And it said that it failed. It said that I have to have a PyArrow installed. So why does it fail? This is because we do the distributed computing. Other computers in Spark clusters should also have the same package installed. My UDF example just now failed because it doesn't have the packages installed in other nodes. Scala or Java provides several ways to manage dependencies across all nodes, like script options, such as like jars or packages and configurations. But PySpark users often ask how to do it with Python dependencies. In Spark 3.1, we added a complete support of Python dependency management in all cluster types. So for example, you can use Conda in your Kubernetes cluster. To use Conda, you first create a Conda environment and install packages you want with the Python version you want. Then after configuring all, you just start, ship, and run it. Under the hood, the Spark cluster automatically untars and place it properly where each executor can locate. And then the PySpark Python environment variable points the Python executable in untarred Conda environment for each executor. Virtual env is also almost the same. You activate the virtual environment variable and install the packages, and then you're done. Just tie it and ship it and run it. In case of packs, it's slightly different. The packs file itself is an executable file rather than an environment like Conda or virtual environment. For example, you execute the PAX file and then it works exactly like a proper Python interpreter. So it doesn't require to compress or pack. You just ship it as a regular file and use it as a Python interpreter for each executors. Okay, so all of them work in all kind of clusters in Spark 3.1. And of course, each approach has a pros and cons. For example, the Conda and virtual env only work in Yarn cluster with Spark 3.0 and lower. And the virtual env and the PAX required to have the same Python installed in the same location for all nodes. There's a blog post that addresses this problem in more details. So please check out if you're interested in. Yeah. Then, yeah, here so far is what's done in Spark 3.1. There are actually more cool things done with Project Zen in Spark 3.1, like a PyPy Hadoop installation option. So please check the Project Zen Jira for more details if you're interested in. And for the upcoming Spark 3.2, I will leave it to you, Hajin.
Thanks, Yafjin. So one of the most important changes in Spark 3.2 is that now you can use Pandas API on Spark. So this is the trend of Stack Overflow question for Pandas, and you can see it has radically increased. Pandas became a super famous data science tool, and it has become almost a standard in this field. Many people start to learn Pandas for data science. But there is one known problem in Pandas. Pandas has a limitation to deal with a large sets of data because Pandas doesn't scale out. Some operation even requires more memory than their size for intermediate copy. And Apache Spark is one of the most common choices to scale their workload out. Spark provides easy APIs for distributed computing and scale jobs out of the box. So this is you have to learn all the PySpark APIs again to migrate your Pandas codes. Many of PySpark data frame API were inspired by SQL APIs, and they have behaviors different from Pandas. For example, you should use select with alias for the rename API in Pandas, and group by and order by for value counts. Also, you cannot do in-place update in PySpark like Pandas does. So another thing is that Pandas has a bunch of powerful plotting and visualization features. So when you want to browse your data, you can use plots in Pandas to understand your data effectively and easily. But you should rely on text in console at PySpark. So suppose I have the Pandas workload like this, and this workload analyzes the number of visitors from two different websites and visualize the total number of visitors by region. So the number of visitors are small. I can run it in Pandas with no problem. So later on, the number of visitors increased and my workload start to fail because the input is too large to process in single node. So now it fails with memory error. So I decided to convert my workload to PySpark because Pandas' read CSV has a different behavior from the default PySpark CSV APIs. I have to configure the options in PySpark codes. And my workload did the in-place update with the duplicating, but PySpark does not allow this. So I have to create another data frame in PySpark. And PySpark does not have the same API like value count in Pandas. So I have to mimic this behavior by using group by, count, and order by. Lastly, I want to merge both counts from both websites like my workload does, because PySpark does not allow the operations on different data frame out of the box. So I have to manually join on the command column and merge them. And finally, I want to draw a plot, but PySpark doesn't have. So the data has to be collected to driver side, converted to Pandas data frame, and plotted by the Pandas API. So there are too many things to change and too many differences to handle. Also, the converted codes are very long in PySpark. and mainly because of the behavior differences. And also, I couldn't plot out of the box in PySpark. So the Spark community took this seriously and raised the discussion and decided to bring the Koalas project to PySpark for Pandas APIs on Spark. So the Pandas APIs are implemented on Spark by PySpark APIs and maintaining the separate metadata to follow Pandas object structures. And the Spark SQL engine takes the responsibility of the execution, so the performance is close to the native Spark SQL. With the Pandas APIs on Spark, you don't have to deal with all the differences and rewriting your code. You just change the single line on the top and it works the same. And another cool thing in Pandas APIs on Spark is that you can easily switch to PySpark data frame APIs. So the existing PySpark users can also easily switch to Pandas context in the middle and switch back to PySpark context with almost zero overhead. Okay, then let me summarize the Pandas APIs on Spark. Firstly, it's Pandas API with distributed computing. And now we can plot PySpark data frame easily out of the box. Also, Pandas APIs on Spark encapsulated immutable PySpark data frame and provides mutable like data frame layer that allows in-place updates and computing on the different data frames. And lastly, you can easily switch it between Pandas and PySpark context. And this was officially proposed as an SPIP in Spark community. So please read the SPIP for more details. Okay, then lastly, let's talk a bit more about the visualization feature in Spark 3.2. Now PySpark can draw a chart for your data. For example, now you can show your data in a histogram plot that uses a machine learning library, Bucketizer, to compute. And also you can draw your data with area plot by taking samples from your data. And also you can draw a box plot that uses Spark SQL expressions to compute the stats need. For all these plots in PySpark, it uses Plotly as the default plotting backend for visualization under the hood. So Plotly is interactive plotting library that allows you manipulate your plot interactively, like zoom in and zoom out. And the chart itself is pretty sophisticated and compared to the other plotting libraries. Another thing to mention is that Pandas actually uses a different plotting backend. Pandas uses Matplotlib by default, and PySpark uses Plotly. So if you want to match the default plot behaviors with Pandas, then you can set the plotting.backend option to Matplotlib. So all these plots in PySpark are implemented in 3 different ways. For some plots, we use PySpark libraries directly, and for others, we use sampling or taking top-end approach. So this is the case when you compute the data by PySpark APIs. Plots like boxplot and histogram are computed by PySpark library, such as machine learning, Bucketizer, or native Spark SQL expressions. And the results are collected to the driver side, and then they are plotted by the plotting backend. So for plots like line and area plots, we use the sampling approach because the sample is good enough to show the general trend and lines. And it becomes too slow to draw a chart when there are too many data points, but there are not many differences in the output chart. And lastly, PySpark uses top-end approaches for plots like PyChart, because it makes less sense to include too many sections with one pie chart. That makes the chart difficult to read. So, all right, I'm going to go through what we talked today. So for Spark 3.1, we talk about the Python typings that allows auto-completion in IDEs and notebooks. And Spark 3.1 also has the new documentation with much more readable pages and live notebook with a quick start. And lastly, the Python dependency management is complete now. And in case of the upcoming Spark 3.2, we introduced Pandas API on Spark that allows many things impossible with plain Spark, I mean the PySpark, like in-place update. That includes visualization support that provides an interactive and pretty plots, and almost 19% of Pandas plots are implemented in PySpark.